So let's talk about the combination of events. So basically, there are two types of events, and the first one is called mutually exclusive events, and the second one called non-mutually exclusive events. I'm going to explain what they mean. So let's move to mutually exclusive events. Two events are mutually exclusive if they cannot occur simultaneously, and by simultaneously we means together. So two events are mutually exclusive if they cannot occur together. So what do I mean by that? Let me use some example to illustrate. So if I toss a coin, a head and a tail cannot show up at the same time. Yes, this does not make sense, because when you toss a coin, you either expect a head to show up or a tail, but both of them showing up at the same time is not possible. So we say that what probability of the head or the event of the head and the tail showing up, they are what mutually exclusive events, because they cannot show up occur at the same time. Also, if I choose a letter from the alphabet, and as the task I want to think of a letter from the alphabet, and that letter that you choose should be both a vowel and a consonant letter at the same time. Now if you think about critically, you see that that does not even make any sense. A letter or an alphabet cannot be both a vowel and a consonant alphabet. It can either be a vowel or a consonant. So what do we say? We say that the probability of choosing a letter of the alphabet that is both a vowel and a consonant is a what mutually exclusive event. And why is that? Because it does not make sense and they cannot occur at the same time. So that is just the general idea. So here is a Venn diagram to represent this idea. So here we have two events, A and B. You can see that A and B are mutually exclusive. And why is that? Because they don't intersect with each other. Assuming they were intersecting, then there will be a possibility for both of them. So let me assume that they were intersecting, then there will be a possibility of both of them occurring at the same time. But we can see that since there is no intersection between them, they cannot occur at the same time. So we see that these two events, A and B, are what mutually exclusive events. How about non-mutually exclusive events? You guessed right, this just represents the opposite of mutually exclusive events, and this represents events that can occur simultaneously at the same time. So for instance, if I choose a number from 1 to 10, it is possible to choose a number that is both divisible by 2 and by 4. So I have two conditions now. I want a number that is divisible by 2, and I also want the same number to be divisible by 4. Now if I choose the number 8, 8 falls between 1 and 10, and I can see that 8 is divisible by 2, because 8 over 2 will give me 4. And also 8 is divisible by 4, because 8 divided by 4 will give me 2. So since it's possible for me to choose a number between 1 and 10 that is both divisible by 2 and 4, I say that this operation or these two events are what non-mutually exclusive, meaning they can occur simultaneously. Similarly, it is possible for rain to fall and for sun to shine at the same time, and we call that phenomenon a sun shower, and you must have experienced it before, when the rain is falling and the sun is also shining. You know that usually when the rain is falling, it's usually dark, but there is also a possibility for the sun to be shining and for rain to fall. So they are not mutually exclusive. So we refer to such events as what non-mutually exclusive events. So here is a Venn diagram to represent this idea. So here we can see that for two events, A and B, they have something in common. So this shaded region that have in common make them to be what non-mutually exclusive events, meaning that they can occur simultaneously. So let's move to the combination of events now. So sometimes we want to calculate the probability of multiple events into one single value. So how do we do this? We make use of two laws, and they include the addition law and the multiplication law or the product law. But in this section over here, or in this particular module, we'll limit our discussion to just the addition law, and later on in the next section we'll talk about the multiplication law. So let's take a look at the addition law. So we have the probabilities of several events when we are finding the probability of event 1 or event 2 or event n occurring. So the key word to note is or. So when you have probability questions and you're having A or B or event 1 or event 2 or I had seen or, put at the back of your mind that what you are going to do, you are going to add the probabilities. So once you see or you are able to infer or from the question, know that you are adding. This will really save you a lot of stress. So put that in mind that or is synonymous to addition. So when you have or, you add. That is the most important thing to remember from here. So now let's try to apply our addition law for mutually exclusive events. So we have said that mutually exclusive events cannot occur simultaneously. So the probability of event A or event B occurring now just because of the probability of A plus the probability of B. Very straightforward. So in general, the probability of A or B or C up to n occurring will just be the probability of A plus B plus C plus the probability of n occurring if they are mutually exclusive events. So let's take a look at an example. And here we are told that a number is chosen randomly from the set of 2, 4, 6 all the way up to 20. Find the probability that it is either a factor of 18 or a multiple of 5. So here you can see the keyword or. So we have to find the probability either it is a factor of 18 or a multiple of 5. So we have to find the probability of factor of 18. Then we have to add it with the probability of it being a multiple of 5. So I'm going to try to figure out factors of 18. So now our total possible outcomes we can see can either be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that gives the total number of possible outcomes when you count it to be equals to what? 10 possible outcomes. So now what is the number of outcomes that is favorable to factors of 8? So now for the factors of 8, now factors of 18 rather, factors means numbers that you can divide with 18 or that can divide 18 without having remainder. So the factors of 18 that in this total set that we are concerned with, we know that 2 is a factor of 18, 4 is not a factor of 18, 6 is a factor of 18, 8 is not, 10 is not, 12 is not, 14 is not, 16 is not, finally 18 is a factor of 18 and 20 is not. So the total number of outcomes that are factors of 18 is just what? 1, 2 and 3. So we have 3. How about the multiples of 5? So for the multiples of 5, how many of our outcomes here represent the multiple of 5? So the multiples of 5 includes 5, 10, 15 like that. So we start out by having the first multiple of 5 here is 10. There is no 15. The next one is 20 and there is a 20. So there are just 2 multiples of 5 here in our set. So the total numbers that are multiples of 5 in our set is just equals to what? 2. And the total number of outcomes is 10. So we can write that now. So now the probability of picking factor of 18 will just be equal to the number of outcomes that related to the factor of 18, which is 3, over the total number of possible outcomes, which is 10. And similarly, the probability of picking a multiple of 5 will just be equal to the numbers that multiple of 5, which is 2, over the total number of outcome, which is 10. So finally, we can write out that the probability of taking factors of 18 or multiple of 5, we just know, since we have this keyboard, or we just have to sum these two probabilities together, will be equal to 3 over 10 plus 2 over 10, and that is 5 over 10, which is equals to 1 over 2 or 0.5. So let's talk about the addition law for non-mutually exclusive events. So how do we apply the addition law? So if you look at this set here, you see that this is a non-mutually exclusive event. So the probability of A or B in this case now is given as the probability of A plus the probability of B minus the probability of A intersect B. As you can see, this shaded region over here is the probability, or is A intersect B, as you remember from our discussion on set. So now when we are talking about mutually exclusive events, we saw that there was no intercept between A and B. So this term was effectively 0. But in this case, when we are dealing with non-mutually exclusive events, we have to find the probability of A intersect B and minus it from the sum of probability of A and B to get the probability of A or B. I'm going to use just one example to illustrate this point. So let's take a look at this. And we're told that a number is chosen randomly from the range of 1 to 20, where x is an integer. Find the possible probability that the number is either divisible by 3 or by 4. So let's write out our total outcomes. So our total outcome, since we are told that it's choosing from range of 1 less than or equals to x less than or equals to 20 and x is an integer, we include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So now we're told to find the probability of a number that is divisible by 3 or 4. So the first thing we're interested in is number divisible by 3. So divisible by 3. So how many of these numbers here are divisible by 3? So the first number here that is divisible by 3 is what? 3. The next is 6. 6 is divisible by 3. 9 is divisible by 3. 12 is divisible by 3. 15 is divisible by 3. 18 is divisible by 3. And that is all. How about the numbers that are divisible by 4? Or the multiples of 4 in other words. So that will include what? 4. Then you have 8. Then you have what? 12. Then you have 16. And finally you have 20. So how many are all these that are divisible by 3? 1, 2, 3, 4, 5, 6. You have 6. And how many are divisible by 4? 1, 2, 3, 4, 5. You have 5. And the total number of possible outcome is 20. But now if you look at the numbers that are divisible by 3 and the numbers that are divisible by 4, you can see that there is a particular number that is contained in both of them. You can see that this 12 is both contained in the numbers that are divisible by 3 and divisible by 4. So what does it mean? It means that these two events are what? Are non-mutually exclusive, because there is a possibility that you select a number that is both divisible by 3 and divisible by 4. So that indicates that we have to make use of our formula. We are talking about what? Non-mutually exclusive events. And we know that the probability of that, in that case, I'm going to write out the formula here. We know that in that case, the probability of A or B equals to what? The probability of A plus the probability of B minus the probability of A intersect B. So now if I take a look at this set over here and I take a look at divisible by 3 intersect divisible by 4, what do I get? I get what? 12, because 12 is both what's common to both of them. So the numbers of elements that are common to both of them is just equals to 1. So to recap, the number of elements in this set that are divisible by 3 is 6. The number that is divisible by 4 is 5. And the number that is common to both of them is 12, and it's just only one number. So I can figure out the probabilities. So the probability of having a number now that is divisible by 3 will just be equals to the total numbers that are divisible by 3, which is 6, over the total number of possible outcome, which is equals to 20. Now the probability of joining a number that is divisible by 4 equals to the number of favorable outcomes, in this case, which is equals to what? 5, over the total number, which is equals to 20. And finally, the probability of divisible by 4 or divided by 3 intersect divisible by 4 will just be equals to what? How many numbers are both divisible by 3 and by 4? You just have only one number, which is 12. So you have what? 1 over 20. So when you apply this our formula over here, so in this case now I can write out that the probability of divisible by 3 or divisible by 4 is equals to what? The probability of divisible by 3 plus the probability of divisible by 4 minus the probability of divisible by 3 intersect divisible by 4. And probability of divisible by 3 is 6/20 plus divided by 4 is 5/20, then minus divided by 3 intersect divisible by 4 is 1/20. And when you sum all this together, you get what? 10/20, which is equals to half or 0.5. So you can see how to apply the addition law when we are dealing with non-mutually exclusive events. So before you try to tackle question, it's important that you ask yourself, am I dealing with a mutually exclusive case or a non-mutually exclusive case, so that you can know the right formula to apply. So that pretty much sums up our discussion on the addition law.